Hello there, and welcome back to another lesson in the proportion module. In this video, we're looking at similarity and scale factors. So I have drawn some shapes for you, some I'm going to have you draw with me, and we will dive right into this with the definition of similar. Similar means having, in math, similar means having the same shape but different sizes. And there is so much you can do with similar shapes in math. You can find the heights of trees, the distance across lakes, all sorts of cool things with this concept. Because here's the math rule. Similar shapes are proportionate, so the rules of proportions will apply. And we'll look at that in just a second. But let me first go through some examples with you, and let's see if these are proportionate. So let's focus on this one first of all. I have a rectangle and a rectangle. One is bigger than the other, but they're both rectangles. These are similar. And when I was in school, I thought of them as a mom and a baby, or a dad and a baby. This baby definitely could belong to that mom. They're the same general shape, but they're different sizes. But we would say in math that yes, those are similar. Okay, this one, I have a square, or it's supposed to be a square, and a rectangle. So there is no way that that baby shape belongs to that mama shape. They're two different families of shapes. They're both quadrilaterals, but they're two different, their attributes as shapes are different. So we would say no, these are not similar. They're not mama and baby. Okay, this one, you can look at that one and tell that, whoa, that is not going to be similar. This is a trapezoid. Now they're both quads, they're both quadrilaterals, they have four sides, but they're not the same. They're cousins, but they're not mama and baby. So no, these are not similar. Okay, be careful with this one. You really have to pay attention. 1, 2, 3, 4, 5. This is a pentagon. 1, 2, 3, 4, 5, 6. Hexagon. Those are not similar. They're two different families entirely. Penta is 5, hexa is 6. So those would not be similar. That baby is not that mama's. And guys, just for what it's worth, when you go on to college, they're not going to talk about mama and baby shapes. I'm just using that to help you get a visual in your mind. Be careful here. This one is tricky because we have 1, 2, 3. 1, 2, 3. So they're both triangles. They're in the same family. But here's the thing. You see how this one has that 90-degree corner and two acute angles? These are all acute. So because their angles do not match, they are not similar. That baby is not that mama's. Now they're cousins. They're in the same family. But because of this 90-degree angle right there, they are not similar triangles. So of all those, I only gave you one example that is similar. And I'm going to have you to draw me another one. So let's come down here to this empty space, and I'll do this slowly so you can do this with me. I recommend a straight edge. But to start with, I want you to connect the dots on 3 boxes. So 1, 2, 3, just like that. And then I want you to go over 4 boxes, 1, 2, 3, 4, and then connect these points right there. And then I want you to draw some vertices. Vertex is 1, vertices are these corners. And I want you to call that A, B, and C. And I want you to also mark that beautiful right angle right there, because that is a perfect, I don't need to make it quite that big, but that has that perfect 90 degrees. And if we count the units here, there are 1, 2, 3 units. This I can count to be 4 units. And I'm going to go ahead and tell you that this is 5 units. And if you've had the geometry course, you'll know why that's true. If you haven't had that one, don't worry about it. We're going to do this with a proportion. Okay, so here comes the second triangle in this series. And I want you to go ahead with your straight edge and draw a line that is 6 boxes long. So 6, and then 8. I don't know what happened to my picture. 2, 4, 6, 8. Even cheating, I can't draw a straight line. And then go ahead and connect these 2. And let's put in the vertices. We're going to call this point D, point E, and point F. And this I can count is 6 units. This I'm going to tell you is 10 units. And then if you notice over here, the instruction for practice problems says to find EF. So we are looking for this segment from E to F. And you may already know it. If not, I'm going to show you how. If you do know it, I'm going to show you why. Okay? So this is also a right angle. So it says first you must decide if the shapes are similar. Is this a mama and a baby kind of thing? And yes, they are. The reason is because they're proportionate right triangles. And because they're proportionate, the rules of proportions apply. So here's how we're going to find EF. And I'm going to highlight in color the 2 pieces that I'm going to be using. I'm going to use this one, and this one, and this one, and this one. Now we could have used the 5 and the 10. I'm just picking the legs this time, but it doesn't matter because they're proportionate. So I'm going to set this up as height over base. And you can call it whatever you want to. And then I'm going to look at baby. And I'm going to look at mama. Okay, so we need to remember a proportion is 2 ratios that equal each other. So baby is 3 units tall and her base is 4. Mama is 6 units tall, and we don't know her base. That's what we're trying to figure out. So draw your proportion, your peanut, and you have 6 times 4, which is 24, and divide by that third number. So Mama's base is 8 units. And you might be thinking, well, duh, lady, I could just count that and I would know. And that's exactly right, you could. If you have this nice dotted paper, that works very well. And I wanted you to see that on the dotted paper so you can tell what's happening here. But these are proportionate similar triangles. So this proportion will help me solve for that answer. Okay, I need to show you how to do a scale factor. And I think I'm going to go ahead and stop this video because scale factor will be a little bit long. So I'll be back in the next one and we'll complete this table at the bottom.